Hi everybody, Mr. May here. Going to be showing you guys some examples from the homework so that way you can complete the remaining problems based off of both the notes and from the work being done here. So let's start with evaluating each expression, numbers 1 through 4. Based on the notes, we know that the log of base b of y is equal to x if and only if we take the base and raise it by that x value, we will get the y. So looking at number 1, we see log of 2, 4. So we say the b is 2 and the y is equal to 4. So based off of this, we know that 2 to the x is equal to 4. So 2 to the what power gives you 4? Well, that is going to be 2. Okay? Taking a look at the second example, we see that b is equal to 3, and y is equal to 1 over 27. So now we can rewrite this example by saying 3 to the x is equal to 1 over 27. So 3 to what power gives you 1 over 27? First you want to think about two things. One, what power will turn a regular 3 into 1 over 3? That would be a negative value. And then you want to think about 3 to the what power gives you 27. That would be 3. So, based off of those two, we know that x is equal to negative 3. Okay? So now you can complete the remaining two examples, numbers 3 and 4, for the first part. Okay? Alright, so taking a look at 5, 6, 7, and 8, we see that we need to find the inverse of each function. So taking a look at the first example, in any of these examples, you need to remember that you need to change places for x and y, meaning that x is equal to log of 5y plus 4. Before you can change any of these to an exponential function, especially for number 5, you need to first bring that 4 over. So now it's x minus 4 equals log of 5y. So change this to an exponential function. You're going to take that base, 5, and you're going to say, well, 5 to the x minus 4 is equal to y. Alright, so there you now have your solution. Okay? 5 to the x minus 4 is equal to y. Awesome. Okay. So, looking at number, let's take a look at number 7, shall we? Okay, so take a look at number 7. We're going to replace x and y like we did in the first example. So we have x is equal to e to the y plus 5. Okay? So first thing you want to do is, after you've done that, you want to bring that 5 over. So we have x minus 5 on both sides is equal to e to the y. So here you are going to need to take the natural log of both sides to get rid of that e on the right side. So our final solution should be the natural log of x minus 5 is equal to y. Okay? Here, for the remaining problems, use these information and stuff in the notes to complete 6 and 8. Okay? Number 6, for that log example, notice there's no base. You need to remember what the common base is for the log in order for you to finish number 6. Alright? So, for numbers 9 and 10, you are going to need to rewrite each equation, as you can see in the example, the directions in exponential form. Okay, so we have log of y, 70 is equal to x. So we need to rewrite all of this. So basically all this information from 9 and 10 is based off of 1 through 4. Alright, so we have, remember, log of b, y is equal to x, if and only if b the x is equal to y. In this case, we have b in our example here is y. So we have y to the x is equal to 70. That's all you're going to have to do. That's all you need to do is rewrite each equation in exponential form. All right? And there we go. There's your solution. So the next part is now we write each equation in logarithmic form. So you're going backwards. All right? So now we're going to go from b to the x equals y back to log of b equals x. So this here, we see that b is 18, and x and y both are what they are in the example of b to the x equals y. So we have log of 18 y is equal to x. Okay? So you should be able to use number 12. Number 12 is using a natural log, so similar idea. Okay? Got any questions? Just give us a holler, alright? Just email us, check in with us just to see. Just make sure you're doing the right thing, alright? We'll post the key to this later on, just in case. Okay, so moving on to the next part. We have to sketch the graph, mark the asymptote in at least 2 distinct points, and then state the domain and range for numbers 13, 14, and 15. So I'm just going to do one of these examples here to get you guys started. So let's start with, I'll just do number 13. So here, number 13, we got to mark the asymptote. So you got to figure out what changed. So what were the transformations, okay? So let's do this. Let's say, transformation. Okay? Well, based off of what's inside the x minus 1, we know it went to the right 1, and then it went up 2. So right 1, up 2, that is going to be your new origin, and we have the vertical asymptote right there. Sweet, sweet, sweet. Okay, so the next thing you need to do is sketch your graph. So we need to make our x and y table. Alright, and we're going to use log of 2x. Alright, so over here, I'll go ahead and say that we have 2 to the y equals x. Alright, so that means we need to pick some points for y. So let's pick the points 0, 1, and negative 1. Okay, again, 0, 1, negative 1 are going to be based off of your x values, and we based off of the new origin. Alright, and we always like to pick 0 because anything to the 0 power is equal to 1. Okay, so there's your first point, 1, 0. Again, it's using the new origin, so that would be this point there. Plug in 1 for y. 2 to the 1 is 2. So 2, 1. And then negative 1 for y would make 1/2. So there's negative 1 going down 1. And there's that. So now you can plot your point. Your graph hopefully will look a heck of a lot better than mine. And now you need to state the domain and range, because that is part B. So based off of this graph, the domain will be starting at 1. As you can see, nothing is going to the left, so it starts at 1, and it's a parenthesis because it can never be 1. So going to the right, it goes to infinity, and then the range is negative infinity because the arrows are going down, and this arrow on the right is going up to positive infinity. Okay, so complete the remaining examples. Got any questions? Just give us a shout. All right, see y'all later.